Arithmetic series can let us add consecutive terms of an arithmetic sequence. Like for example, if we have arithmetic sequence here, 1, 3, 5, 7 until 2n minus 1. Getting arithmetic series would be like this. Now, since we are adding consecutive terms of an arithmetic sequence, we would want to know what could the sum be. Now, we can have here a formula or an expression for us to know the sum right away of consecutive terms of an arithmetic sequence. So in this case, this is actually n squared. Now, you might ask, first things first, will n squared work? Let's check. What if we want to add the first 3 consecutive terms of our arithmetic sequence here? So this would give us 9, right? Now, applying this formula, we are to consider 3 consecutive terms. So n here would actually be 3, and if we'll square that, the answer is 9. But how to get n squared? That would be with the use of this n over 2 times the sum of a sub 1 plus a sub n. Now, a sub n here would mean the nth term. That would be this. A sub 1 would mean the first term. That is 1. And we just have to write n as is. So, n over 2 times a sub 1, which is 1. A sub n would be r2n minus 1. Simplifying that, or the inner terms, would give us just 2n. And since we are multiplying here, we can now cancel the 2's, and we're left with n squared, n times n. There we go. Now you might investigate by asking, what if you want to get the sum of the consecutive terms of this arithmetic sequence, but you don't want to start at 1? Say you want to get the 3 consecutive terms of the sequence, but starting at 3. Clearly, n squared will not work for that, because n squared would only work if we start at 1 here. Alright? So if you want to get the 3 consecutive terms of this arithmetic sequence, but this time you want to start at 3, then might as well have your arithmetic sequence here, 3, 5, 7, and so on. Change the nth term here. And the nth term here would be 2n plus 1 instead. Now, apply the discussion earlier for you to get the sum of the consecutive terms of this arithmetic series, which would give us here 3 plus 5 plus 7 plus until 2n plus 1. Since it's n over 2 times a sub 1 plus a sub n, that would be n over 2 times the first term, which is 3, plus our nth term, which is now 2n plus 1. That would give us n over 2 times 4, and that to be added to 2n. Now, let's simplify this by factoring out 2. This would just be n plus 2. Cancel the 2's, and we're left with n times n plus 2, or that would be n squared plus 2n. Let's check if that works. It says n squared plus 2n. So if you want to get the first 3 terms this time, the sum of the first 3 terms, consecutive terms, solving that would give us 15. So let's check if this would really be 15. We are considering 3 consecutive terms. So this would be 3 squared plus 2 times 3. This is 9 plus 6. And that is really 15. 7 plus 3 plus 5 is still 15. There you go. But if you're clever enough, you may do this. For as long as you're applying the rules of math correctly, then no problem. Why not? Since we want to know this time the sum of the consecutive terms of this arithmetic sequence, but you don't want to start at 1, you just want to start at 3, why not just get the sum of the first 4 consecutive terms of that arithmetic sequence and just subtract 1. Right, we can do that. Now, getting the sum of this first 4 consecutive terms of that sequence, knowing that it will be based from the n squared, the formula that we just solved earlier. So we want to get the 4 consecutive terms. So that would give us 4 squared, which would mean 16. And 16 would be the sum from 1 until 7. But we just want to get the sum starting at 3. So just subtract 1. And that will give us 15. Still the same with our example earlier. Correct?